Alrighty, let's graph this trigonometric function. There are two things happening to this sine graph. This 3 and this minus pi are doing two different things. The 3 right here, the number in front is the amplitude. So my amplitude is 3. That's an important thing. And what is this negative pi telling it's going to do? Well, the negative pi at the end is a horizontal shift. And it goes opposite of negative, so it's going to be going right pi. So what we have here is a sine graph that's going to be stretched up and down 3 and pushed to the right pi. And real quick, a sine graph has a midline like this, and a sine graph looks like an S. So it's going to look kind of like that with 3 points hitting the midline and an amplitude up and down. And that's what we're going to look for here. But we are going to start at pi instead of at 0. Now a sine graph always has a period of 2 pi, so we could write that down. Your period is 2 pi. And since there's nothing added at the end back here, the midline is 0. Alright, so let's graph this. But the first thing we're going to do is start at pi. So I'm going to mark this as, right here, I'm going to make this pi. Okay? So if that's pi, and my period is 2 pi, that means there's 2 pi, and that would be 3 pi. So if I'm going to start here at pi, because I got pushed to the right pi, that's where the graph's going to start. And if the period's 2 pi, that means we're going to go 1 pi, 2 pi away, and that would be the end of this sine graph. And there's a dot in the middle, so that would be here at 2 pi. So you also have another dot right there. Alright, so we're going to have a dot halfway between. We're going to have a high amplitude. Halfway between, we're going to have a lower amplitude. So halfway in the middle here, which would be right here, you're going to go up an amplitude of 3. So we're going to go up 3 right here. So let's see, that would be up 3. So let's just say we have 1, 2, 3. So we're going to be up 3 right there in the middle. And as well as right here in the middle here, you're going to go down 3. So we're going to go down 1, 2, 3. So this is going to be right there, down 3. And so I have my graph like that, which should look just like this graph. So I have a graph, boom, 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 boom. Kind of missed that, sorry. It should hit right there. Missed that a little bit. And if we have to go farther on both sides, you could continue it. Hopefully you'll notice you go halfway down, you hit another one. So you could go like this to extend. We could go over here to 4 pi and keep this going halfway up would be a 3 and then back down. So you could keep it going on either side, but this blue part is the basic parent graph that is shifted right pi, amplitude 3, and the period of a regular sine graph is 2 pi. Alright, for this one, we have 3 things changing. Actually, 4. Alright, so let's look at it first. What is our midline? Well, right there. So your midline is y equals 1. What is your amplitude? Well, it's right there. So that would be a 2. But realize there's also going to be a flip. That's important to realize. And our period, or our period here, is related to that. That's b. So it's going to be 2 pi divided by 4 pi. Okay, you always take 2 pi and you divide it by that number right there. And when I reduce that, I get, this cancels, I get 1/2. So my period's a half. So those are the 4 things happening. We are going to have a midline at 1. You're going to be flipping it and going up and down by 2. And your period is a half. It is a cosine graph. So a cosine graph that's upside down will look like this. You're going to start here, go up like a hill, and back down. That would be a cosine graph. Your midline's through the middle here. So you have a midline right there, and you're going to have another point right there, there, there. So there's 5 points for a cosine that's negative will look like this. So, but now we got to do the amplitude and all that, those pieces. Nicely, there's no horizontal shift. that makes this one a little bit easier. So we first start with our midline at 1. So put a line right there, that's 1. So there's our midline at 1. Our amplitude is 2, but we'll hold off on that one. Our period is a half. So let's just say my graph goes to here. I'm going to call that a half. Kind of weird. So right in the middle of that would be a quarter. It's a really narrow graph, but it's a half, because that's what my period says. So our whole graph is going to be halfway. One period is a half measurement. Okay, with that said, okay, so it looks like we're going to start low. So what is that height? What is the amplitude? It is a 2. So our first value at 0 is going to be 2 down. So I'm going to go 1, 2. So there is my first dot. That's negative 1, and that's positive 1. So I went 2 down. All right, and if you look at a cosine graph like this, it's going to end at the end of the period also down there. So it's going to end down there at the same 2 values below the midline. Halfway between, right here, it's going to go up 2. So we're going to go 1, 2. So it's going to go up 2. Now, you notice these 2 dots? We have to put those 2 dots on. So those are always on the midline, and they're always halfway between. So halfway between right here, you're going to hit the graph, and halfway between, you're going to hit the midline. Okay, so this right here is the graph. It's going to look like that right there. That is one cycle of this graph. It's been flipped, amplitude of 2, up and down 2. It is a period, a b is 4 pi, which makes it 1/2 period, and its midline is 1. There you go. Now you could keep this going. You can keep it going, make another cycle of it, but we're just going to go one cycle. Alrighty, we're going to graph this function. There are 2 things happening to it. Our midline for this one is just still y equals 0. There's it's y equals negative 1. We do have a shift right here. So y equals negative 1 is my midline. The amplitude is 1. The period is not changed. So my amplitude is still 1 because there's a 1 hiding up here. My period is going to be, 2 pi divided by 1 because there's a 1 hiding in front of that. So that would just be 2 pi. But you have this, which is a phase shift, which you do the opposite of positive, so you're going to be going left 2. So this graph is going to start left 2. So first step we want to do is to put our negative 1 midline. All right. And we are going to do a cosine graph. So a cosine graph starts high, ends high, drops low, and has that look, midline through the middle, and has 2 dots down here. I always like to draw that sketch before I start. So this is what we're looking for, and it's going to be revolving around this, but it's starting 2 units to the left. So let's just say that right there is negative 2. So that is where we're going to start. We're going to start right here. But that's not the value of what we're going to start at. Okay, we are actually, forgot about that, from the midline, the amplitude's 1. And if you notice here, we go up 1. So from here, we're going to go up 1, and our first value is actually right there. All right. So this is going to be a little tricky. Our period is 2 pi, which is approximately 6.28, because 3.14 times 2. So my period, this is my first dot, and if I'm my next dot, this length from here to here is a span of 6.28. So if I'm at negative 2, this would be 0. This would be 2, length of 2. Okay, that's 4 from here, so that's 2, 4, 6, and a little bit more. So my next dot is going to be a little bit farther than 6 away. So again, this is 4 and 2. So if this is my first dot, 6.28 away is my next dot, according to this picture down here. Halfway between is my low piece. So halfway between, we're going to go down 1. So what's halfway between? Let's just look. Let's think maybe that's halfway. I'm not going to make it too perfect here, but I'm going to call that halfway. All right, and then halfway between this and this, let's say it's right there. So I'm going to say halfway between is right there. It's going to hit the midline. And halfway between this and this is about right there. So it's the midline. So right here is my graph. That right there would be my graph of this right here. And we can make more cycles if we want. Again, it has a midline of -1, amplitude of 1, period of 2 pi or 6.28, and it started 2 points to the left. So a little bit tricky, but there we go. All right, let's graph this tangent graph. So for this tangent graph, we have two things changing. We have this and this. Our midline is y equals 2. There is no amplitude, but our a value is 1. Tangents don't have amplitude, but they do have an a value. My period is pi, and the number in front here is a 1, so it's pi divided by 1, which is pi. All right, and my shift, well, with it right here is my shift, which you go opposite of negative, so we can go right, pi over 2. So that's all the pieces we're going to consider. All right, and a tangent graph looks like this. You start here at the midline. You start there, you end there. There's going to be a tangent line down the middle, and then it goes like this. It goes whoop and whoop. That's what we're looking for, something like that. So let's do it. So again, we are starting at the midline. So let's make a midline of +2. So 1, 2. Got my midline. Sounds good. We got that done. Now we have to start at pi over 2. Remember, we're going to the right, pi over 2. So let's just make a line right here. Let's call this pi over 2. And I'm going to put a dot. That's where I start. Remember, I'm putting this dot right there. All right. Now what would this dot be? It is going to be pi over, because tangent has a period of pi and 1 divided by 1, so it's pi. All right, so let's go 1 pi degree away. So if that's pi over 2, well, this right here would be pi. So this right here would be 3 pi over 2. So this would be your next dot. Okay, so the distance from here to here is a half pi and another half pi. This makes a full pi. And the asymptote is going to go right down the middle. So let me draw an asymptote right down the middle. All right. Now if you want to keep going, we're going to make another dot. So let's see, if we make another dot, let's go another half and then a whole. So put another dot, and we could actually put another asymptote. With tangents, it's sometimes nice to put more than just one graph. Okay, we could keep going, but let me stop there. Okay, so I have this graph that looks like this. How do I know? Okay, it's going to go up against the asymptote. Now, the one thing is, the distance between here to here, the middle point is right there. How do we tell how high we go? It's the a value. It's not an amplitude, but a value. So at this point, we're going to go up the a value. All right? So halfway between here, you're going to go down the a value. Halfway here, you're going to go up the a value. Halfway here, you're going to go down the a value, and so forth. Or you could think of halfway here, you're also going to go down the a value. So watch what happens. Your graph will look like that up through the asymptote. If you want to go this one, it will look like this. I didn't tell you there was an asymptote here. We can talk about that. I mean, you can kind of think of why, but okay, ignore that for a second. Now for this one, your graph is going to look like up near the asymptote, hit this, there we go, and then cut across and up near the asymptote. Okay, and then for this dot right here, it just goes up and then goes across, and that's good enough. So there's several cycles of it. Now, just so you realize, one cycle of the tangent graph, just to think about it, is right here. This right here and this right here, that is one cycle of a tangent graph. Okay, this to this is one cycle. Now, most people think of it as the right here, between those two things, but this is really one cycle of a tangent graph, but you can visualize it anywhere. But because we started at pi over 2, we had to think about starting right here. That was important, and ending right here, creating our singular cycle. It is, again, harder for people to see this as a cycle. It's easier to think in between these two asymptotes as this as a singular cycle. Alrighty, our last problem. It's a tangent with a -2 and a 3. So our midline is y equals 0 because there's nothing added or subtracted. Our amplitude, there's no amplitude. I keep forgetting your a value is -2. That's going to be important. But there's no amplitude. Your period, well, your period is going to be pi divided by b. So pi divided by 3, pi over 3 is your period. All right, and there's no phase shift. So one thing is, because of the negative here, you know your graph's going to kind of look like that. Okay, so be aware it's going to kind of go down. So let's check this out. Okay, let's start off with, always starts here at 0, 0. All right, we're going to go one period is at pi over 3. So we're going to hit here at pi over 3. Halfway, we are going to have an asymptote. There we go so far. So we have starting here, ending here, asymptote down the middle. It's a -2. So what that means is halfway between here and here, halfway, I'm going to go down 1, 2. All right, and then halfway between here, I'm going to go up 1, 2. Okay, so what does that really mean? Well, if you look at the graph, your graph's going to look like that. And this graph's going to look like, kind of hitting it weird, that. Do you see kind of like that look? Now, you can't really see that look because we haven't extended it out, but there is one cycle of tangent. It has a -2, it's going dropping by 2, halfway between you went up 2. It kind of looks like a sine graph if you connected those dots. If you ever think about that, it's like a sine graph, but it's not. So that's one cycle of it. Let's just do another cycle. So if I put another green line over here, that would be 2 pi over 3, because you go another pi over 3. This right here is going to be your asymptote down the middle. And then, well, halfway between, we would go down 2. Halfway between, we would go up 2. And if you think about it, your graph would look like that. And then right here, your graph would look like that. And what you'd hopefully see now is you have that shape right there. And that would be your tangent. Remember, the -2 went down. Remember, there's no amplitude, but your amplitude gives you these key points. The halfway between, how far up or down you go. It gives you how it's called a horizontal stretch. So, but that's the basic idea. Tangents are probably a little bit harder than some for some people. Good luck with graphing trig functions.